Okay, good day all. So today we are going to look at the concept of mole. So what is a mole? A mole is defined as a quantity of a given substance. It's defined as a quantity of a given substance that contains the same number of elementary entities. So when we said elementary entities in chemistry, elementary entities can be one, it can be a molecule, it can be a molecule, or uh, it can be formula units, it can be atoms, ions. So all these are considered as an elementary entities. So ions, atoms, formula units, and molecules are considered as an elementary entities. So a mole is defined as a quantity of a given substance that contains the same number of elementary entities. And these elementary entities can be molecules, formula units, atoms, ions, etc. as the number of atoms contain, or as the number of atoms in exactly 12 grams of carbon-12. So now, carbon atoms, for example, now let's look at this. The carbon atom has a mass of 12. Then the copper atom has a mass of 63.5 grams. So now, but all this, if you now look at it, 1 moles of carbon contain exactly 12 grams, and 1 moles of copper contain exactly 16.5 grams. But in 1 mole of each of these elements, either the carbon and the copper, they contain the same number of atoms. And this number of atoms is 6.02 times 10 raised to the power of 23 atoms. So it means that in each and every element, or in each and every substances, 1 mole of each of that substances contain 6.02 times 10 raised to the power of 23 atoms. So it's the same. It's the same, provided that the number of moles are the same. And one very interesting thing is actually we have a different formula for calculating mole. Number one, I'm going to list the formula here. We can calculate mole as mole is equal to mass all over molar mass. So you can calculate mole as equal to mass all over molar mass. When we said molar mass, it means the total mass of an individual element in a given compound. So if you sum them together, it will give you the molar mass, and it's usually expressed in gram per mole. Like now, for example, let's say we have calcium trioxocarbonate 4. And now we want to calculate the molar mass of this calcium trioxocarbonate 4. So each and every element has its own atomic mass. So calcium have atomic mass of 40. Oxygen or carbon has atomic mass of 12, while oxygen have atomic mass of 16. So if you now want to calculate the molar mass of calcium carbonate, what do we do first? Now we look at how many calcium do we have. We have only 1 calcium. So we are now going to say 1 times the mass of calcium is 40. So because we only have 1 calcium, that is why we said 1 times 40. That is for calcium. And then now we move to carbon. How many carbons do we have? We have only 1 carbon. So therefore, since we have 1 carbon, then we open another bracket. Then we now say 1 times 12, because the mass of carbon is 12. So we are now going to say 1 times 12. Then after this, then we now move to oxygen. How many oxygen do we have in this compound? It's 3. So we are now going to say 3 times 16, because the molar mass of oxygen is 16. So after you add everything here, 1 times 40 is 40. Then we have 1 times 12, we have plus 12. And then we have plus 3 times 16, we have 48. So when we add everything, we have 100. gram per mole. So this is how we calculate the molar mass of an element. So we may have actually, apart from the molar mass, usually in some cases, the mass of an element or the mass of a compound will be given. Let's say here, the mass of calcium carbonate weight, or the weight of calcium carbonate weight in weighing balance, let's say is 16 gram, is 16 gram. So now we want to calculate the mole. So since we have 16 gram of calcium carbonate and already we calculate the molar mass. So how did we get the mole? It's simple. We are now going to say mole is equal to the mass of calcium carbonate is 16. So we are now going to say 16 divided by 100. So 16 divided by 100 is the same thing as 0.16, and the SI unit of mole is mole. So this is actually one of the formula for calculating mole. So one, mole, it can be mass all over, molar mass. And then we also have another formula for calculating mole. We have another formula for calculating mole. And that formula, it can be 1 mole is equal to number of particles is equal to number of particles or number of atoms, number of elementary entities. It can be any of either number of molecules or number of atoms or ions. So it can be number of elementary entities. So let's say here, number of atoms. Okay, let's say number of atoms here, number of atoms all over Avogadro's number, because Avogadro's number is constant. So you can just say mole is equal to number of atoms all over Avogadro's constant, which is 6.02 times 10 raised to the power of 23. So we can, this one is always constant. So we can calculate mole with this. So mole, it can be the number of atoms. So yes, the number of atoms all over 6.02 times 10 raised to the power of 23. It might not always be number of atoms. As I said, it can be any elementary entities. It can be number of molecules. It can be number of atoms. It can be number of ions. It can be number of particles. So that is another formula for mole. So you can actually be given a number of moles and you may be asked to calculate the number of atoms, and it's simple. It's just maybe, let's say we have the mole of, we have let's say we have 0.5 mole. We have 0.5 mole. We have 0.5 mole of carbon dioxide, CO2. So if we have 0.5 mole of CO2 and we now want to calculate the number of atoms that are present in 0.5 moles of carbon dioxide, is simple. We are now going to set, okay, it's 0.5. So now we are now going to replace this mole with 0.5. So we now have 0.5 is equal to the number of atoms, divided by 6.02 times 10 raised to the power of 23. And from here, you can just simply do cross multiplication, which at the end, it will now end up of multiplying. We're now going to set number of atoms is equal to 0.5 times 10 raised to the, 0.5 times 6 times 6.02 times 10 raised to the power of 23. Then at the end, after we now do all the calculation, we will now end up of having 3.01 times 10 raised to the power of 23 atoms. And what does that mean? It means that 0.5 moles of calcium carbonate contains 3.01 times 10 to the power of 23 atoms of carbon dioxide. So apart from this, we also have another formula for calculating mole. We also have another formula for calculating mole. And this formula is this mole. Mole is equal to volume. Mole is equal to volume all over 22.4 dm cube. So this is also another formula for calculating mole. You may be given a volume of a particular gas and you ask to calculate the mole, or you may be given the mole and asked to calculate the volume, and it's simple because the standard volume at STP, that standard temperature and pressure, is 22.4 dm cube. So you can easily do the calculation. Then we also have another formula for calculating mole, which says mole, which is N. You can use N to represent mole. So mole can be concentration, which is C. So concentration times volume. So concentration times volume can be used to calculate the mole. So this is also another formula. So I think, ladies and gentlemen, this formula, as I mentioned them, as I list them, they are very, very important, and you should try as much as possible to see how you will apply them. So as we continue with the lectures, we are going to look at how we are going to apply all these different formula. Okay. So now, introducing the mole. This Avogadro's number is actually given by a scientist called Amedeo Avogadro. So a mole is a number of atoms or molecules in 1 gram of hydrogen or 12 gram of carbon. So in a simple way, if you ask to identify or to define a mole is defined as a number of atoms or molecules present in a compound or in an element. It's a number of atoms or molecules present in 1 gram of an element. So the number, which is 6.6 times 10 to the power of 23, is called 1 mole. It's called 1 mole, or Avogadro's constant, in honor of Amedeo Avogadro. So 1 mole of atoms of any element will have an equal, or will have a mass equal to its relative atomic mass expressed in gram. So now we are also going to look at, under mole concept, there are 2 things that we are actually going to look at, and they are very, very important. Under mole concept, we are going to look at what we call atomic number and the mass number. And remember, ladies and gentlemen, in an atom, we have what you call a shell. This is called shell. We call it shell. Or in the other way, we call it orbits. We call it shell or orbits. And in this shell, we have one of the particles of an element. And this particle of an element is electron. And this electron is negative charge. It has negative charge. And of course, remember, the first scientist that was able to discover electrons is J.J. Thomson. J.J. Thomson. In the year 1896, that is J.J. Thomson. So this scientist, J.J. Thomson, was able to actually discover these electrons, and it has its own properties. And how this scientist was able to identify or discover this electron is actually by applying, high, high, high voltage, high voltage and low and very low pressure in a fluorescent tube. So as he increased the voltage and decreased the pressure, he was able to observe that the fluorescent tube began to glow. And that is how he observed that there are some rays that are emitted from the cathode to the anode. So J.J. Thomson is a scientist that was able to discover electrons in the year 1896. And these electrons is located on the shell, and the electrons have negative charge. And then after this, we have nucleus. And in this nucleus, we have what you call proton. In the nucleus, we have proton and neutron, and neutron, and neutron. Protons have positive charge. It has positive charge, and the neutrons is nil. It doesn't have any charge. And of course, remember from the general nuclear chemistry, why do we call it nuclear chemistry? Why do we call it nuclear chemistry? We call it nuclear chemistry because it's the chemistry that talk about the nucleons. So it's the chemistry that deals with actually the change that occur in the nucleus of the atom. So it means that the nuclear chemistry, we are talking about the chemistry of nucleons. And what is nucleons? When we said nucleons, it means just protons and neutrons. So protons and neutrons is the nucleons. So that is why in nuclear chemistry, we are not actually talking about electrons. Electrons is only applied to general chemistry, organic chemistry, and other branches of chemistry. But in nuclear chemistry, we are just talking about the nucleons. Remember, nuclear chemistry is the chemistry that talk about the exchange or the types of the rearrangement as well as the reactions that are taking place just within the nucleons. And of course, you can't talk about the nuclear chemistry without talking about radioactivity. And remember when we said radioactivity is a rapid or is a spontaneous disintegration of the unstable nucleus, is the spontaneous disintegration of unstable nucleus. Disintegration means breaking down. While when we say spontaneous, it means that are substances that break on their own. They break down on their own without the need of any external agent. So it is on their own that they break down. So why is it that these elements are breaking down? Is because they have unstable nucleus. And how can you know that the element have unstable nucleus? Is when an element have a neutrons to protons ratio. If an element have neutrons to protons ratio greater than 1.5 or less than 1, if it is greater than 1.5 or less than 1. So if it is greater than 1.5 or less than 1, it means that that element is having unstable nucleus. So since the element is having unstable nucleus, it means that it will undergo the spontaneous disintegration, meaning that the element is a radioactive element. And how do you know that the element is having unstable nucleus? Is simple. You can just look at, let's say, uranium. The atomic mass of uranium is 238. Okay, I think before we start with this, I think let me also explain this concept. So what is atomic number? So remember, I told you in the nucleus, we have protons and neutrons. So atomic number is just the number of protons contained in the nucleus of an atom. So if you sum the number of positive charge, that is the protons, in the nucleus of an atom, if you sum them together, you have atomic number. So it means that atomic number is the same thing as the number of protons of an element, while the mass number of an element is the sum of protons and neutrons. So if you add protons and neutrons in an element, if you add the sum of protons and neutrons of a particular element, it means that you have the mass number of that element. So A here, this is the representation of this radioactive elements. So it is the representation of an element. So the X here represent the symbol of an element, while the A here represent a mass number, while the Z here represents the atomic number of the element. So now, if we have U here, we have the mass number is 238. So remember, A represent mass number. So therefore, we have 238. So this 238 represent the mass number of the element. And then, of course, the mass number of uranium is 92. So therefore, it means that the atomic number of uranium is 92. So now how do we get the protons to neutrons ratio? It's simple. Remember we said that the mass number Mn, the mass number Mn is equal to proton plus neutron. So what is the mass number of uranium is 238, is 238. And then the proton number, what is the proton number is 92. So we are now going to set 92, then plus N. Then how do we get N? We now take 92 to the other side. So we have 238, minus 92 is equal to N. So when you say 238 minus 92, 238 minus 92, let's see, 238 minus 92, I think it's simple. This minus this, we have 6. Then this minus this, we have 13. Then 13 minus this means we have 4. So we have 146. So we have 146 as the number of neutrons. And of course, the protons is 92. So now, how do we now do the calculation? How do we get the neutrons to protons ratio? Then we are now going to set N divided by P. That is neutrons divided by protons. So the neutrons is 146 divided by the proton, and the proton is 92. So divide by 92. Then at the end, we have 1.59. 1.59. So you see, this 1.59 is greater than 1.5. So therefore, uranium is a radioactive element. Uranium is a radioactive element. So it has unstable nucleus. So therefore, it will undergo radioactivity. Therefore, it will undergo the rapid breakdown. So it will undergo rapid breakdown. Then the next thing that we are going to talk about apart from this is an isotopes. So what is an isotopes? An isotopes are elements that have the same atomic number. Isotopes are elements that have the same atomic number but different mass number. So this is chlorine. So atomic number of chlorine is 17. So this is atomic number. This is atomic number. Remember, any number that attach somewhere around here indicates the atomic number. So an isotopes, it means that an element that have the same atomic number but different mass number. They have the same atomic number but different mass number. So the atomic number of chlorine here is 35, and the atomic number of chlorine here is 37, while the atomic number still remains 1717. So that is the isotopes. And in the other way, you can also define isotopes as an element having the same number of protons but different number of neutrons. How do you do that? You see, atomic number is the proton number. So therefore, in chlorine 35, the proton number here is 17. And then in chlorine 37, the proton number is also 17. But what about the neutron number? The neutron number, you now say this minus this. So 35 minus 17, we have 18. So it means that the neutron number is 18. And then we have 37 minus 17. Then we have neutrons number is equal to 20. So therefore, we see that the protons number are the same, but the neutrons number are different. So you can also define isotopes in this within this term, that isotopes are elements that have the same atomic number, but different, that have the same proton number, but different neutrons number. And ladies and gentlemen, one very important thing that you need to understand, atomic number is what determines the chemical properties of an element. The chemical properties of an element are identified based on their atomic number, while the mass number determines the physical properties. It's an indicator of physical properties of an element. So now in this case, we are talking about the atomic number in fluorine 35 and 37 is 1717. So therefore, you can define isotopes as an element that have the same chemical properties, but different physical properties because the mass number are different. So ladies and gentlemen, I'm now going to stop for this video and I will upload another video. Thank you.